In this video, I'm going to go over the unordered linked list class that was assigned in class. Okay, so it's based on the linked list. Okay, so I've got this here, the right thing here. So we start with this linked list type. Okay, so this is an abstract class, okay, which means we can't make an instance of it, okay, and it is an abstract class because it has some pure virtual functions, okay. So we're also including this iterator here. So the iterator is going to be a way for us to move through our linked list, okay, and it defines the plus to go to the next item of the linked list, and it defines an asterisk as the dereferencer to return the values that are there, okay? So here's the normal thing here. And again, because this is storing memory data or dynamic variables, we need to make sure of a couple of things. We have to overload the equals operator, okay? And it just calls the copy list. Again, it avoids a self-copy here, okay? And then we initialize a list. It's the same thing as just storing a list. We get it back to nothing, okay? We've got an is empty. We've got a print function that we've got a length destroy list, which just gets rid of everything. Note that when we're destroying the list, we're not just removing it, okay? We're actually deleting it, okay? So what we're doing here, we're going through a list here while the first, remember this has a first, a last, and a counter. While the first is not the end, so when we're not done, we're creating this new node temp that we're copying equal to first. It points to the same memory address, okay? We're then moving first to the next item of the list. We're then deleting temp. So this is actually deleting. You can just delete the reference or close the program, and you have not freed the memory, and your program would have a memory leak, okay? So what we're doing here is avoiding that, okay? There's a front, which returns what's at the first. We could also do a first info as well, but front and back are just ways to make programs function a little more logically, okay? And here are the virtual functions that we have. So we have a search, we have an insert first, insert last, and delete node. These are all pure virtual functions. They have the virtual keyword at the beginning and the equals 0 at the end to make them pure virtual, okay? So these we're going to defer to the children of linked list, okay, which are going to be ordered and unordered. And the reason being, the search will be different, okay? If you're searching an ordered list, then you know if the current info is greater than the search term that you're done. And if not, if it's an unordered list, you have to search the whole thing, okay? The same thing with insert first and insert last. You don't really do those in the same way on an ordered list, like as you would on an unordered list. And then the delete node is not as different, but could be different depending on what's going on, okay? So note that all of these use the templating here, okay? And just a note on how the book does things as opposed to how I do things, okay? So I define my functions here in one CPP file, okay? I don't have a separate header file. There's nothing wrong with having a separate header file. It's something you probably want to do the more you program, but for right now, I think it's easier to keep track of. In the same way, I just define the functions right here, okay? So the book has them separate, I have them right here. So I just have to have one of the template class type here, okay? Before that starts. So those were the ones down here. As we move down, the virtual functions that we're going to have to do, okay? And then here's the iterators have the begin and the end, okay? We're going to use those. Here's the default constructor, okay? Here's the copy constructor. Again, because we're storing memory data, we need to have a copy constructor to avoid making shallow copies. We're making actual new copies of things. And then there's also the destructor. Okay, the destructor has the same name as the constructor and the class, but with the tilde in front. And it's just going to destroy the list when we're done. So we don't have to worry about that. It's automatic, okay? And then we have the protected data. So remember, protected is kind of in between public and private. Other instances of the class or other things that inherit from the class can get to these. So they're less protection than private would be, but not quite as open as public. Okay, so we have a count, that's how many items there are in the list. We're going to keep that up as we go. And then we have node type pointers to first and last. Okay. And then the private, we have a copy list that gets called by functions that we're doing. That's really all we have that's private. Okay. So that's the basis that we're going to do both the unordered and the ordered lists from. Okay. So it's important that we have that going. Okay. So back up to the top here. Okay, so we're including in this one, we're including the linked list iterator type. Okay. So let's take a look at linked list iterator. Okay. So there was some question from some of you on where the struct goes. The struct just has to go somewhere that gets included. Okay, so we have the struct, in this case, this is what the book did. The struct is defined in the iterator. The iterator was included in the linked list type, which then is included in either the unordered or ordered. So you just have it once and you're good. You can't define it twice. So they chose to do it there. That's what I'm doing as well. Okay. And then this is just going to have some public functions. There's where we create it with the current. There's another pointer here. And here's the big things. We have the asterisk, which returns the current info. And we have the ++, which returns what's at the current position. Okay. And the this keyword, we'll see here in a minute, this refers to the instance of the class that called the function, basically. Okay. We're also defining here the equal and not equal, basically. Okay, and that's it. And it keeps this pointer called current. Okay, that's what you get from the iterator type. Okay, so now let's look at the unordered linked list. Okay, so again, the purpose is a little hard to read, but I'm including IOStream. I'm including the linked list type. Okay. Now the IOStream is interesting, and the using namespace standard are both interesting. If your program or your class definition doesn't do any CN couts, then you don't need the IOStream. I usually put it in there anyway. It will make your programs bigger. So it's something to think about design-wise. For now, it doesn't matter, but just know that you're adding a bunch of bulk to your programs by including those if you don't need them, okay? So we also have to include the linked list type because we're going to inherit from it, okay? And again, one templated class for the whole thing, because that's how I'm defining it, where I'm doing the functions all together, okay? The advantage to just doing the prototypes, with this version, if you want to see what all the functions are as a documentation exercise, it would be difficult. You'd have to scroll through the whole thing. So by putting them all up at the front with just the prototypes of the functions, that it's easier to read. But to me, easier to do is more important than being easier to read at this point. Okay, but they both work, and the book does the opposite. Okay, so here are the functions that we have to define. Okay, it's the obligation. So well, actually, let's go back up here. This line, we're doing the inheritance from linked list type. Okay, so we're doing a public inheritance, and we're passing along this type variable here. That's how we have to declare things. Okay, and then we have our public search function. Okay, and the book has this. You just had to type it in. So again, this constant protects the search item itself doesn't change. This constant means the list doesn't change. The search shouldn't change things. Okay, so we're getting a current node type here. Okay, we're setting the found equal to false. We're then, and this is just because our compiler is different, and I'm not 100% sure the technical reasons, but I found that whenever they do the first, the last, or the count, you have to prepend it with a this, and then with the arrow or the dash greater than. Okay, so we're setting current equal to first element, and then while while it's true that we're not at the end and it's not found is false. Okay, which we set false, found up false up here. We're going to see if the current info is equal to the search item. If so, found is equal to true. then next time we come around, this while will be false, and we'll go ahead and return found. If not, we're just going to move to the next item. Okay, we're going to let current equal to current link, and that's going to go all the way to the end. Okay, so either we'll return a true if it finds it, or a false if not. Okay, insert first is relatively straightforward. That's like inserting at the head. Okay, so it takes a new item. Note there's a constant here. The new item shouldn't change, but there's not a constant out here because the list will change. Okay, so this is the general way we do things. We're going to create a new node. Okay, we're going to allocate memory. So we need the new. So these steps are important. So it's new node type, new node. Okay, and it's new node type. Now, when we have a test program, the type will be something, an int, a float, a string, whatever. Okay. We're then setting the new item that was sent in to be the info, and the link will be first, because the new link is the first, so that's the old first, and the first now points to the new node. That's how we're putting that in. We're also incrementing the counter with the plus plus, so counter is equal to counter plus one. Okay, and if this last is empty, which means the list was empty, we've now added one item. It's the first and the last. Okay. The insert last follows in a similar vein. Okay, except we're going to the end. Not much different there. Okay. So the delete node gets a little more exciting here. We have some cases. The first case is if the list is empty, then you can't delete from an empty list. Okay. Case two is that the list only has one item. Okay. So you find that one item, and then now you have an empty list, basically. Okay. And it goes through the search on that. The case three is that there is the item and we find it. And then case, yeah, here's you find it and delete the node. Okay. And then case four, I think is that down here that it's not found. Okay. So that's what that looks like. So let's look at the test here. So we have four functions. We have the search, the insert first, insert last, and delete node. And we want to make sure that we test all of those in our test program. Okay. So I've created this unordered test program to show you what we're doing here. Okay. So I start off declaring unordered linked list integer u. Okay. So it's going to be an unordered linked list. Okay. And it's going to be of type int. So that type, capital T type, everywhere else in the other code will be an integer in this case. So I need to test out the four functions. I'm putting an insert first to put a 5 there, and then I'm inserting last at 10, 2, and 12. Okay. Again, for a test, you don't have to allow user input. You can just force it to do what you want it to do. I'm then counting that the list should be 5, 10, 2, 12. Okay. And then I do the U print, and hopefully that looks the same. Okay. Next, I'm going to test the search. I'm going to search for a 2, which should be correct. Okay. So I'm going to, if the U search 2, didn't need this anymore. That was a test. That was a test. Yeah. So if I do the search function on a 2, it should be found. But if it is, I'm going to print found. If not, I'm going to print not found. Okay. Then I'm going to search for a 22, which should not be found. So that should print found, then not found. Okay. And then on the deletions, I'm going to go ahead and delete some of the cases here. So I'm going to delete from the front, so the 5. I'm going to delete the 2, which is in the middle. And then I'm going to delete the 12, which should be at the end. Okay. And I can also, while I'm doing it, and then I'll break it and it won't work. It's going to, let's delete. Try to delete, let's say 50, which is not a thing. Okay, so I'm going to do u dot delete node 50. Okay, and that should give us the error message, and then the u dot print should remain the same. Okay, so when I compile this, okay, -o unordered test.exe unordered test.cpp. Okay. See, I knew I was going to make a mistake. Control V makes you go down further in the code if you need to. Left out the semicolon there. That's the only issue. Okay, then I can // unordered test ex.exe. Okay, and you see what we're doing here. So I have the list should be 5, 10 to 12. It's 5, 10 to 12. I search for 2, it's found. I search for 22, it's not found. The list after 5 is deleted should be 10 to 12, and it is. After the 2 deleted, it's 10, 12. After the 12 deleted, it's just 10. Okay. If I try to delete 50, it tells me the item to be deleted is not in the list. Okay. And then it prints the list again, which is nothing. Okay. And I guess the other thing we can test while we're here is go ahead and delete that last item. The 10's all that's left. So let me go ahead and say we want to delete last item. That's the other case that we haven't tried yet. U.delete node 10, then a U.print. Okay. See what that does. By the way, I'm using a program on the Mac called Warp Terminal, which I really like. It makes it very fast to do things. Compile it, looks okay. Let me run it. Yeah, and it's when we get to after the last time, it didn't give us an error. We go to print and it doesn't print anything, which is what we want. Okay, so that should be it. That should be how this works. Okay, so I think it's important that we understand how to use these data structures. Okay, I'll say again, if you're having difficulties, now's a good time to ask questions. If you need me to do a video on anything, any of the problems we do in class, any of the concepts that you're unclear on, then make sure that you let me know. One thing I am going to do, I'm going to create, or I may already have a video on segmentation faults. Okay, so that's something that we're starting to get and we're going to continue to get. So look for that video soon. Okay, as always, if you have questions, make sure that you let me know.